Now we're going to talk a little bit about the digital communications. So first and foremost, and I've gotten this question a couple of times, digital communications is not the same as digital input. Digital, again, just means really a binary language of 0, 1. So in digital input, it's just switching between two parameters in a controller. Digital communications, on the other hand, is a full coded language, really, that allows devices to talk to each other and send in information back and forth. So digital communications is a lot more in depth than what you might see with the digital input. And some common protocols you might see might be Modbus, Ethernet, Profinet, DeviceNet. I didn't put it on here because it's more common in heat trace, but BACnet I know is a popular one. So all those digital communications are something that our customers might be using and might try to get out of our controls to make it basically easier for them to send information back and forth. So real quick, again, I don't want to dive too deep into these concepts, but I thought just giving you guys a base to kind of get an understanding of these protocols, of the different types of them. So Modbus, probably everyone's heard Modbus. Really all it is just a language that was developed by a company, Modicon, basically bought out by Schneider Electric. And it's really, if we were to call any of these to be the industry standard of digital communications, Modbus is probably that one. It's more widely used across industrial devices. Not specific to any one brand. It really does carry across a lot of platforms. The next, what I would call maybe the second most popular in industrial world would be Ethernet. It's used a lot. It transfers information across the Ethernet cable. A lot of Allen Bradley devices use the Ethernet language. So if you're working with a customer that has Allen Bradley, that might be the language you're looking for to communicate back to our controllers. Profinet's another one. This one is, the net side of it is Ethernet, so it's transferred over Ethernet, but really the Profi language. It's an industrial Ethernet, so it transfers a lot faster information. There's a lot more bandwidth than what maybe the Profibus, which a lot of people get those confused. Profinet, Profibus. Really, what's the difference? Again, Profinet being the faster industrial Ethernet version, Profibus being a little bit more simplified serial communication. The difference, though, is Profibus was adopted by Siemens. So again, like we said with the Allen Bradley device, if you're working with a customer who's using a Siemens PLC, they're probably going to be looking for a Profibus connection. And again, a lot of our controllers, I shouldn't say a lot, but a number of our controllers, especially the newer ones, do have the capability for those Profibus cards. And then another one, DeviceNet, again, transferred over Ethernet. This language is actually common in the automation industry. And again, it's one that Allen Bradley uses. So I would say more likely than not, if you're dealing with Allen Bradley and it's not Ethernet, they're probably trying to use DeviceNet, which again, some of our newer controllers do have that capability. And then last, EtherCAT. I've actually seen this a lot in the packaging industry. Ether being Ethernet, so again, transferred over Ethernet, but different language than necessarily the Ethernet or the DeviceNet we're using. So again, you'll see those in different industries, different manufacturers of PLCs might have a standard version they might use in those different languages. And this is by no means an all-encompassing list. This is kind of just the ones I think I've seen come across the most often. Didn't, again, talk about BACnet just because it's more in heat trace with building automation, but in the industrial world, you'll probably run across one of these guys. Okay, so that's, kind of what to look for with digital communication. So now another question I've gotten fairly frequently is, what do I choose? Do I use analog? Do I use digital? What's the right choice for me? And really, it comes down to two questions you can ask. First is obviously what's available. If a customer has a DCS or their SCADA system and they have the capability for these, for example, Modbus, then maybe that is the right way to go because they have the functionality there. They're probably using Modbus for other things. Maybe it's just easier for them to integrate that into our controllers. On the other hand, if they don't have that network, then the answer is pretty easy. They can't use digital communications. So if they are trying to send something back and forth like that remote set point, well, really analog is their only choice. But the next question is really what's necessary. So just because it's available doesn't mean that they have to use it or they should use it. So the way to kind of distinguish between those two things is an analog signal is carrying one parameter. So again, it's either the process input, it's either the remote set point, or the retransmit of the process variable. It's only one thing that's going on in the controller that's being passed on, versus digital, where you're sending whole packets of information. Everything from manual operation, remote operation, set point one, set point two, anything the controller's doing can be passed through those digital communications back to the customer. So if they're only asking for one thing, they probably don't want to go through the whole process of mapping the controller just for that one parameter when they can just send a simple analog signal and be done with it. But if they are going for more of the information, more of those parameters, you can't really do that reasonably in an analog configuration. You're best to go through the digital. So if you ask yourself those two questions, you can really key in on what they're going to need or what they're going to want to use. And I have got this question before too. Can I use both? So if a customer is, let's say, using Modbus and they want to send a remote set point and they want to, should they do it through analog or should they do it through the digital communications? Well, most of our controllers, you can even set it up to have analog and digital. Occasionally, I think there are some builds where you might be able to pull that off, but the question is why you would want to. It's really basically a redundant feature. If you're using Modbus already, you can do everything through that. You can send remote set points, you can read process variables, you can do all that. There's really no point in having that extra analog signal unless there's just some preference the customer has to isolating that one variable. But I really don't see that happening very often. And then also a lot of the controllers, they use the same slot. So you can see on the right-hand side there, that's just a snapshot, I think, of the 40 series controller. Pin 16, 17, 18, that's the RS-45 Modbus card. You can see that's also where the remote set point card would go. So if you're using one, you can't use the other one. So again, if you're using the Modbus, you can probably just handle everything through that. Okay, so we've talked about what it is, some of the different names. Now let's talk a little bit deeper about some of those different languages and what they mean, because I do get a lot of questions on these. I know some of these concepts are pretty confusing at first, and today I don't want to go too far because I know we'll probably get lost in some of the weeds here, but I think getting just kind of a grounding for what these concepts are might definitely help. So when we talk about the digital communications, you're often going to see it laid out in a language and a transmission type. So I have a couple of examples here. So Modbus RTU RS-45 is a common one we see. In that case, Modbus RTU is the language that's being talked between the devices, and RS-45 is the transmission type, or the connection or the cable type. Modbus TCP over IP is still Modbus. You're still talking the same language, but how the information is transferred back and forth is different. The TCP over IP is using Ethernet cable. So I have a nice little reference over there to the fax machine. So if you can imagine picking up the phone and calling a fax machine, it's not going to go through, right? You get all those beeps and the fax machine doesn't know what you're trying to do. It just can't talk to each other on those two different devices. So that's kind of how it works with Modbus RS-45 versus the TCP over IP. Same language, different type of connection. Ethernet IP, the third one I have there, you can think about that as Ethernet being a language, but also the transmission type is the Ethernet IP cable. So compared to Modbus TCP over IP, they're talking two different languages, even though the connection type might be the same. So you have to be very cautious when you're working with customers, making sure that you're talking about the same thing. Because I have had people, I have a little note at the bottom there. I have had people say, hey, customer's looking for Ethernet. And in their mind, they're just thinking of that Ethernet cable they plug into the controller. In reality, they're looking for Modbus TCP over IP. Again, it's using that Ethernet cable, but it's not the language Ethernet over IP. So asking that question is very critical to making sure that we're talking about the same thing that the customer is looking for. Okay, so that's basically what it is and some of the different names, but how do we actually make this work? What is it actually doing? So you can think about the controllers, that everything that is going on internally to that controller, whether it's the set points or setting the PID parameters like we talked about in 101, switching between alarms, setting the alarm set points, all that information is being stored inside the controller in a unique location. So, and I apologize again, with all the protocols, they kind of use different terminology, they use different mechanisms. I'm going to kind of standardize what I'm saying on Modbus because I think that's the most common and easiest to really understand. So when we think about the controllers, all these are going to be really at addresses or locations within the controller itself. So Modbus, again, you're going to use an address. Ethernet uses what's called an EDS file, and that uses tagging and other mechanisms for identifying where those parameters are. Profinet uses their thing, Profibus, et cetera. I have those listed there. So we won't go into those. I think that's just going to confuse it. The concept I'm trying to take away from here is is just knowing that all those parameters have a unique location in the controller, that once the customer pairs with our device, we give them that map and say, here's where you can find this parameter. And then they can map to it. And then that way, if they want to pull something, they can do so. And here's an example I would give. So we've been talking about the analog a lot. If we look at a customer who wants to set up a process input using an analog, let's say it's from a transmitter, how would they do that through the Modbus? So on the right-hand side, again, I think this is from the, I'm sorry, actually, this might be from a CFW controller. But either way, this particular controller, the analog input type would be stored on address 27. The scale would be 29 and the maximum scale would be 30. So what they would do on their end is they would basically have their master device that's going out there and looking for that information. We tell them, hey, if you're looking for the analog input type, go to address 27. And you can see on there on the table on the right, RW means read or write. So if they just want to see, hey, what is that analog input type set to, they would read to that address. They would call to the device. Our device would see that, hey, the master device is asking me a question about address 27. It sends it back to them and says, my analog input type is 4 to 20 milliamps. So if that works for the customer, that's great. If they want to change that, they would then do a write command and the same kind of interaction would happen. Same with the minimum scale, maximum scale. It's all about back and forth. The master calls for information and our devices send it back to them. The important thing is that they know where to find it because of how those addresses work. That minimum, excuse me, middle comment, I actually added that this week because I don't know if Dan Gutman's on the phone, but he had a customer that was trying to map to our device, and I thought this was a good thing to throw in here at the last second. They had asked, hey, I need an address for all these parameters, so we sent them the manual, and our manual only has 2-digit codes, and they were kind of confused by that. Well, no, I need longer codes. Well, some devices actually start their addressing at 40,000, 30,000, maybe it's 30,001. So it's important to understand that our manuals, when they show those addresses, those are offsets. So they would basically add whatever we send to them to whatever their base address is. So if their master starts at 40,000 and they're looking for what the analog input type is, which is address 27, they would add to it, and therefore they would map it to address 40027. So again, I don't want to go too far down that rabbit hole, but that was an important distinction because I know there was some back and forth and some confusion on that. And hopefully that was resolved. I don't know, again, if Dan's on the line, but hopefully that was resolved. But again, after you've mapped to it, the customer's device is set up. They know where everything's stored. Then they can basically read, write parameters back and forth on regular intervals. And it can be, again, anything the controller's doing can be sent back and forth. So again, we look at analog, you're only sending one thing. Digital communications, you have the whole controller basically mapped out if you want to.